Good morning. My name is Peter Kovacs. I'm the assistant professor at the Agronomy department working in cropping systems. And today we'll talk about some of the corn studies what we are doing in the past 3 years, and mainly focusing on the nitrogen rate and nitrogen application timing. Those of you who are not familiar, but if you look at the nitrogen cycle itself, once we apply the fertilizer, and most of us, or at least most of you, are applying this fertilizer prior to planting, over time will convert into ammonium and the nitrate form. And this is what we really want to avoid, to convert that fertilizer into a nitrate form early, because if we have wet conditions, that nitrate can leach towards the groundwater, or if we have too much water, it can also go through on the denitrification process, which can lose the variable nitrogen for our corn what we are growing. So what we do in this study, we try to target or compare the pre-plant nitrogen application prior to planting versus if we are splitting up our nitrogen about these V3 growth stages, which shortly after planting, or try to time our majority of our nitrogen application or nitrogen rate about this V5 growth stages. Why is that important? Because if we are looking some of these plants, this is the growth stage and this is the development stage of the corn when they are start to take up a lot of nitrogen. So in the past month or month and a half since we planted these crops, we had plenty of rains, and since I'm here in South Dakota in the past 3 or 4 years, seems like all the spring were fairly wet. So if we apply all of our nitrogen prior to planting, we have a really good chance of losing this nitrogen from the corn. So before we go to what we see this year, I want to go and show you some of the results what we get in the past couple of years. So in 2018, we can see the 3 different lines would represent the black one would represent the pre-plant application, the red line would represent the V3 application, and the blue line would represent the V5 application. So in 2018, looking the different rates, we didn't see any differences between these application strategies. At the V3 and V5 applications, we applied 40 pounds of nitrogen at planting, and the remainder of the nitrogen rates, what we applied here as a total nitrogen, was applied at these growth stages. If we are looking the 2019 results, we can start to see the benefit, and if you recall how wet it was last spring with all the delayed and prevent plant stories, we can start to see that once we applied our nitrogen, all the nitrogen at planting, that resulted the lowest yield out of these 3 scenarios. So what we can see that both with the V3 and V5 applications, we were able to increase our grain yield while we kept about the same nitrogen rate where we could maximize this grain yield, which was somewhere around the 150-170 pounds per acre nitrogen rate. If you look at some of our plots here, this plot is actually on my right hand side, which we applied at V5 application. And it was interesting when we applied and when we did our V5 sampling, the field across, the farmer was also applying his V5 nutrients at the same time. So I was certainly glad to see that some of you are using this split strategy. What I also want to show that we are at the early V7 or so growth stages, and this would be a zero nitrogen or a corn from the zero nitrogen plot, and this one is from our 160 pounds of nitrogen, which we applied everything prior to planting, that we can start to see some minor differences, that our pre-plant 160 plots are start to showing the better looking corns. If we compare, I also have another corn. Both of them received 160 pounds of nitrogen. However, what I'm holding in my left hand, so this corn, this was applied with a V3 strategy. So if we start to compare the two plants, we can start to see that with this split strategy, this corn starts to grow better, or at least now start to be taller. So again, this would be a good example what we can see that if we have really wet planting conditions or really wet spring around planting time and shortly after, we could lose quite a bit of nitrogen, which can translate into grain yield at the end of the season. And again, this is the growth stage on the corn where they will require a lot of nitrogen moving forward. So this is our goal, that to provide nitrogen, available nitrogen for these plants by this time, that they are not short on the nitrogen at the way where we are not endangering environment. So this project was funded by the South Dakota Nutrient Research and Education Council. So this is our last year for this project, but hopefully we can continue our work related to corn and nitrogen with my collaborator, Dr. Jason Clark in our department.